Our project is Web Graph Machine Learning by Rainville and James McBennett. It starts with an introduction, and below is a map created in leaflet.js. Users can create a linear building or a courtyard building by drawing a polyline or a polygon. Selected coordinates display towards the bottom of the screen that are automatically converted to real-world dimensions and moved to the origin. Users can edit other options from the default values. Clicking Calculate Graph will unhide the 3.js container, displaying the 3D model. It will take a little time to send data to the backend, process it, and receive it back. The returned result is parsed for coordinates of each node and the prediction of whether that node is unit, egress, or corridor that are used to create the 3.js model. For future development, this logic could combine Grasshopper and machine learning predictions to create a Revit template with levels and initial geometry preset making use of Rhino inside. Then lastly, we have this GIF to further display our workflow showing the front end sending a JSON to the back end, prediction happening, sending another JSON back, and creating the 3.js. And then some further information with links at the bottom.
For a second example, let's do a linear building. A new geometry on the map will automatically replace the previous one, and those new points appear in the coordinates container. Pushing the Calculate Graph button again will clear the 3.js scene, getting it ready for the new geometry. A new JSON is sent to the backend. The nodes and edges are created with the execution of the Grasshopper file by Rhino Compute, and the color of each node and edge is determined using the pre-trained machine learning model. Opening the browser console shows both JSONs in their raw format. This is the second of the two JSON files, the file returned from the backend. It shows the coordinates and the predicted label of every node. Scrolling up shows the initial JSON that was sent from the front end with new coordinates, the corridor type set as single loaded, the typology set as linear, and the number of floors as 2, matching the geometry displayed in the browser with egress successfully predicted.